Okay, in this question here, we have a rectangular playing field. We want to enclose it in 400 meters of fencing. The fencing wants to enclose the largest possible area. What dimensions should we use? So our isolating equation is the one with the answer, and that is the 400. So let's draw a picture. I have a rectangular field with a width, a length, and a length, and the perimeter is 400. So that means that all the way around the rectangular field, I'm going to use 400 meters of fencing. So width plus length plus width plus length will equal to 400, or 2 widths plus 2 lengths will equal to 400. Now I notice everything there is divisible by 2, so I'm going to divide everything by 2, and I get width plus length equals 200. So I just want to isolate for one of my variables, doesn't matter which one. I'm going to subtract W, and I end up with length is 200 minus width. So that's my isolating equation, which I will use in my substituting equation. I want the greatest possible area, which is max area, and that's length times width. So my max area is length, 200 minus W, times width. So we'll distribute that inside the brackets, and we end up with 200W minus W squared. Or let's write that with our leading coefficient first, negative W squared plus 200W. So that's what I'm going to complete the square for. So let's go up here, negative W squared plus 200W. I factor out the leading coefficient, which is a negative 1. So negative W squared divided by negative 1 is W squared. 200W divided by negative 1 is negative 200W. So close my brackets, give myself a bit of room. So in my grid, W squared goes here. Negative 200W is split into 2 equal pieces, just like that. So factoring that out, I have a GCF of W in this row. I take the leading coefficient out, negative 100. I have a GCF of W here, and then I take the leading coefficient out. So I always like to check W times W, W squared, W times negative 100, negative 100W, negative 100 times W, negative 100W, and negative 100 times negative 100 is positive 10,000. So 10,000 is going to complete my square. So I add it, and I also subtract it inside the brackets. Again, I do that because 10,000, take away 10,000 is 0, and you can add 0 to anything without changing its value. So let's complete the square. Here is my perfect square trinomial. So that factors as W minus 100 times W minus 100, or W minus 100 squared. Then I have to worry about that negative 10,000 inside. So I'm going to take out a negative 1 times a negative 10,000. I take that out, and I'm left with positive 10,000. So let's write the vertex. The vertex is opposite of the inside, straight up what the outside is. So that's my vertex, 100 and negative 10,000. So this tells me what my max or min is. This tells me when my max occurs. So since it's negative, I have a parabola that opens down, which means I have a maximum. So in terms of this question, the maximum area is 10,000 meters squared. And when it occurs, well, we had W's. When it occurs is when W is 100 meters. Now let's figure out the length that goes with that. There we are. The length is 200 minus W. And we just know W is 100, so 200 minus 100 is 100. So that means that my length is 100 meters. So let's look at this all together, and let's just check with the question. It says, what should the dimensions of the field be, and what is the maximum area? So here are the dimensions, 100 by 100, and here is the maximum area of 10,000 meters squared.